Hey students, so this video is going to just guide you on a couple of examples of how to again complete the square when solving quadratic equations. So before we start, I just want to give you the preview once again of what are we doing. A quadratic equation is a parabola. When you find the solutions, you're finding the x-intercepts. Of course, graphing in your calculator can easily just identify where they are. But algebraically, you need to find ways to do it, especially because we now have imaginary solutions sometimes. So we have the methods of square root method, square root property, and then we have the quadratic formula. I'm going to write property. And then we have also factoring. So now we are doing completing the square. And all of these are methods. So of course you can choose from one from another. They all just have preferences, right? So quadratic formula only works in standard form. Factoring only works also in standard form. Square root property tends to be easier whenever you have vertex form. So the ax minus h squared plus k. And then the completing the square is pretty much going from standard form to vertex form. And then from there, kind of like following again with the square root property. So this is the one we're doing today. We are converting standard to somewhat vertex form and then continuing with what we did with the square root property. So here is the standard form. And the first thing you want to do is multiply your a value times What you want to do is you want to keep this section of ax squared plus bx. You want to keep that section and move that to the other side. So that -6, you add 6 to both sides, cancels, and you're left with x squared plus 4x equals 6. And why did we do that? Because we want to create right here a perfect square trinomial. So you're going to rewrite it again, but now leave a little space right there and put equals 6. So how can we write a perfect square trinomial? Well, we need to look at the b value and think of what number can go there. So I showed you yesterday why the formula of b over 2 square works to give you that answer right there. It has to do with completing a square literally. So this 4x is pretty much from having 2x and 2x together. So that means you divide this by 2 to find out what those numbers are. And once you find out those numbers, how do you get this last number up here? Well, you pretty much multiply the number up here and here together. So you square it. So that would be a 4. This is the visual of this formula. So scratch that and let's focus on using the formula just because it's easier. So b value is 4. You're going to have 4 divided by 2 square. And then you simplify that. 4 divided by 2, that is 2. And then 2 square, that is 4. Okay, so we're going to put a 4 on this side. And just like in any other topic in math, what you do to one side, you do to the other to keep the equation balanced. So now we have x squared plus 4x plus 4 equals 10. And then this perfect square trinomial, what you're going to do now is quickly factor it out with 2 equal binomials. So kind of like thinking of what goes outside this box. Well, we said 2 and 2 is what gives you that 4. So then x and x is what gives you that x squared. So how do we get plus 4? Well, both of these have to be positive. Because if you combine these two, they have to give you that positive 4 in the middle. So a positive 2x. All right, so we're almost there. This can now be written as x plus 2 squared. And then this is what I meant about all this process to kind of write it like a vertex form. Vertex form will just simply be moving the 10 to the other side. But for now, we keep it like this because we're going to now use the square root property method, which is square root of both, cancels that squaring, and now we have x plus 2 equals square root of 10. From here, you ask yourself, can I simplify square root of 10? So off the top of your head, if you can factor out the 10 into numbers that are perfect squares, so perfect squares meaning 1, 4, 9, 16, 25, 36, all of those perfect squares. Can 10 become a factor of the perfect squares? No, 10 cannot. So what you want to do is just leave it alone and rewrite it as plus or minus square root of 10. And now to get the final answer, we need to get rid of this 2 right here. And I know I ran out of space, so I'm going to write smaller, minus 2 on both sides. Cancels, and your final answer will be x equals negative 2 plus or minus the square root of 10. Okay, I'm going to zoom in just to make sure you guys see that. So I'll write it up here. X equals negative 2 plus or minus the square root of 10. A lot of work, but I write big, so maybe you can write smaller and it looks less work. So I'm going to do one more example, and then you guys please take care of the others. Here we have, again, wanting to keep this side and move that negative 5 to the other side. So we're going to add 5 to both sides, cancel, and we're left with x squared minus 8x. Leave a little space right there to save yourself some steps, and then 5. So now how do we find that missing part right there? The formula b over 2 squared helps you find that. So b is negative 8. Negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Negative 4 squared. And negative 4 squared is 16. So we're going to put 16 right there. And what you do to one side, you do to the other. So you also add 16 over here. On this side, we have 2 binomials that are going to give you this. And then 16 plus 5 is 21. X times x gives you that x squared. And 8 and 8 give you that 16. I'm sorry. So here we have, not 8, I'm sorry, 4. 4 will give you that 16. 4 times 4 give you 16. Yeah. So then how do we get 8? Well, we combine negative 4 and negative 4 together, and that gives you negative 8. So then that is written as x minus 4 squared equals 21. So all that work that we did right here, I kind of shortened it a little bit. So now let's go ahead and do the square root. So that cancels the squaring. So x minus 4 square root of 21. Well, once again, you think about, can the 21 be factored into any of these numbers? 21 is 3 times 7, 1 times 21, and I think that's it. So it can't. So what you're going to do is just square root of 21. Then you move the 4. And then your final answer will be x equals 4 plus or minus square root of 21. All right, again, it's just another method. So if you can do it, let's go for it. If you can't do it, just try it. Try it for me. You have classmates around you that might be able to help you. All right, have a good one.